Now we define combination. Combination is a selection, and here is an important part. It says unordered selection. So that's what we mean by selection. It's a selection of R objects from N distinct objects. A selection, you're simply grabbing objects from those N distinct objects. It's the best illustration would be, you have a bag full of N objects, and you're simply grabbing them, and it doesn't matter what order you grab them. You simply, take a subset of those of that set of N objects. So a selection is basically a subset, and it doesn't matter what order you have listed them. Whereas a permutation, you not only take the objects, but you have to put them in an order. So for example, again, if we have the 5 objects, like in the previous example, we have 5 different objects and we are ordering or selecting 3 out of those 5, then again, let's use the slots. Here we have 3. And the first slot, we could, for example, put the letter A. Let me list the 5 objects here. The second object could be C. The third could be D. Or I could have A, B, and E. And so each one is a selection. Now, however, I want to make sure that you understand that if you switch C and D here, so that's the same as this one. It's the same selection. So we cannot use the same formula for permutation, obviously, and so we will have fewer number of selections compared to the number of permutations. To express permutations, and we used tuples, but to express selections, to express combinations, we simply use subsets. So this is a CD. This is a selection, and it has the elements A, B, E. This one is A, D, C. But as you know, in a subset or in a set, the order of elements are not important. So this is the same as A, C, D, which is exactly the same as the top one, the same set. So we use subsets or sets to express selections. Now here's an important question. How do we find the number of combinations? What is the number of combinations of R objects from N distinct objects? What is the number of combinations of 3 objects from 5 distinct objects? And you probably know a formula for a combination, but it's important to know where that formula comes from and how it's obtained. And I'm gonna show you how we do that. In this way, we can obtain the formula easily, and we don't have even to memorize the formula. We can simply get the formula easily by understanding how it's found. First, let me state a fact, and the fact is this. The total number of combinations can be obtained from the total number of permutations. And to understand that, let's compare a permutation with a combination. Again, let's use, in our illustration, let's use R equals to 3 and N equals to 5. In other words, 3 objects out from the 5 distinct objects. Now here is a permutation. Let's take a look at one combination, one of those combinations that we seen before. Well, let's take this one, A, B, and C. Now, when we look at this combination, again, this is a set. The order is not important. So if you list A, B, C, or A, C, B, or B, A, C, all of those are the same combination. Now, from this combination, from these 3 letters, we could enforce order. So let's enforce order. And by doing that, then we are creating permutations out of this combination. So if we say that the order is important, then we can create several permutations from this combination. So we can have the first one, A, B, C. That's one. Here's another one, A, C, B. Right? We simply swap the 2 last letters. Or we could start with B and then AC and then BCA. We have a CAB and CBA. So we have a total of 6 permutations out of those 3 letters, out of that single combination. Now, so what is the total number of permutations that we get from this combination? Again, let's use the slots. This time is not for those 5. We're just doing permutations from these 3. Let's forget about the 5. So we have the 3. We want to permutate these 3 elements. So the first slot, we have 3 possibilities, because here we're permutating only A, B, C, okay? So we want to know how many permutations we get from this combination, from the A, B, C. So the first slot, 3 possibilities. The second slot, 2 possibilities. The third slot, just 1 possibility. So that's a total of 3 factorial. 3 times 2 times 1, 3 factorial. Or you can simply think of 3 permutation 3 comma 3. We're permutating all 3 objects from those 3. And notice that it doesn't matter if it's ABC or any other 3 letters. The number of permutations that we obtain from ABC or any other 3 letters is always 3 factorial. Now let's look at the big picture. Notice that this is one combination, and that combination will generate several permutations. That one single combination generates 3 factorial permutations. And that is the relationship that we get. So we can generate all the permutations. We can get all the permutations from the combinations. So every combination yields 3 factorial. So here is the total number of combinations that we don't know what it is, but we know that each one of them generates 3 factorial. So if we multiply that times 3 factorial, we should get all the permutations. And that is the relationship. Now from this relationship, we can easily get the combination formula. So combination of 5 objects, of 3 objects from the 5 different objects is permutation 5, 3 divided by 3 factorial. In general, we can extend this formula to N and R. CNR is PNR divided by R factorial. And again, the reason is that when we have R objects out of N, then if we consider a combination that has the R objects, that specific combination, that particular combination, will generate R factorial permutations. So that means that each combination generates R factorial permutations. That means the total number of permutations is combinations times R factorial. So it's the same formula. And that's the relationship. Now we could get a formula from here since we know what the permutation formula is. Right? Permutation formula, if you remember, it's n factorial divided by n minus r factorial. And this is divided by r factorial. Right? The top one here, the top number is permutation. So this becomes n factorial divided by n minus r factorial times r factorial.